Welcome back to the video. Today we're doing another Leetcode medium, doing 1980, find unique binary string. Instructions we're going to skip because the examples are pretty good. We're given an array or a list called nums, and it's going to have binary numbers in there. They're all going to be the same size, and they're going to be composed of ones and zeros. What this Leetcode question wants is return like a combination of ones and zeros that is not in the list. 1, 1 is an option, or 0, 0 is an option. And they just have to be the same size. So this case would be 2. There's this example, they have to be size 3, and we have to return a number that's not in the list. So 101 would count, 00, and so on. The way we're going to do this, we're going to generate all the combinations of ones and zeros with the same size, and then we're going to see if it's inside of nums. If it's not in nums, we could just return it, and then we're done. So let's actually code it up. So we're going to need a variable. We're going to call it n equals length, and then length of nums at 0. So we're just getting the length of the first entry in the array. In this case, n is 2, the length. Length is 2 here, and then the length n is 3. And then we can iterate through the array. We could say for I in range, we could do 1, kind of pay attention to this part, shift over left by n, and I'll kind of explain this right now. So we want this loop to iterate as many times as we can make combinations. So when we're shifting 1 over by n, say we have the number 1, and n here is 2, because there's two numbers. Shifting it over by 2 would give us, first let's have the number 1. Shifting it over by 2 to the left means we have 2 zeros in front of it. Now we have 1, 2, 4. So this loops can iterate 4 times because there's 4 combinations: 1, 2, 3, and then 4. For this example, n is 3. So we're going to go back to example of 1 and shift it over 3. 1, 2, 3. 1, 2, 4, 8, and there's 8 combinations of these ones and zeros that we can make. So that's all that for loop is doing. That's all it's doing. Okay, so now we have to construct a binary string. So we could call it bstring equals to format, and we want to format I. We want to have leading zeros, and then we want to do plus the string size of n. And then we're going to tell it to format it as a binary string, as a binary number. I don't know why I said binary string. And here we can check if bstring is not bstring not in nums, not in nums. When they say Python's like English, I was literally almost writing it in English. If it's not in there, we can just return the first one. We don't have to keep looping through it. We just return bstring, or if not, we could just return -1. It's kind of like default. If I didn't miss the only thing, it should run first try. So pass all the test cases. And it should be a pretty fast implementation because as soon as we find bstring, we're done. Pretty much, yeah. 100% runtime. So yeah. If this helped you in any way, please leave a like and subscribe.